For dust collection system, this is another mechanical system. So ito yung sample view ng dust collection system sa woodworkings, sa shop nyo. So yung mga dust dyan, pupunta dito. Every equipment meron yan. So tapos, dapat naka 45 degrees, 90 degrees. Yan, para yung capture niya. So, punta dito sa dust collector. Dust collector, yung dust may ipon dito. Tapos na yung malinis na hangin or pwede mo i-recirculate sa ventilation. So, yun. So, dito, itong dust collection is, ang velocity dito is mataas. High velocity ductworks. Introduction. Dust and fumes have been a part of industrial life for many years, and the hazards associated with them are well known. The disease and respiratory disorder found in foundries, factories, and cotton works are examples that are familiar to many. This need not occur with a better understanding of control measures and more efficient equipment. So sa DNR, they require to air pollution controls equipment. So what is the nature of dust and fumes? Dust can be said to be a solid broken down into powder. And the form that it takes will have different effects on the body. Fibrous dust can attack tissue different directly, while others may be composed of poisons which are absorbed into the bloodstream. Fumes can be regarded as very small particles resulting from the chemical reaction or condensation of vapors, which can have the same two effects. The standard unit normally used for measuring dust particles is the micron, 1,000 of a millimeter. May micro-inch. So the smallest particle visible to the unaided eye is between 50 to 100 microns, and the most dangerous sizes are between 0.2 and 5 microns. Particles larger than this are usually unable to penetrate the lung defenses, and the smaller one settles out too slowly. Some dust can be both toxic and fibrous, that is asbestos, and are therefore harmful even outside this parameter. So it therefore may be assumed that dust which are visible, that is between 50 and 100 microns, are quite safe. However, this is not the case, as dust cloud never consists solely of particles of one size mix. Analysis would show percentage of all sizes, and it is for this reason that special care is needed in measuring dust cloud and concentration. The next most important factor to consider when assessing dust cloud is the actual amount of dust present. This is known as the concentration, and is defined as follows. A substantial concentration of dust should be taken as concentration of 10 micron or 10 milligram per cubic meter, 8-hour time-weighted average of the total inhalable dust, or 5 milligram per cubic meter, 8-hour time-weighted average of the breathable dust, where there is no indication of the need of a lower value. Control of dust and fumes. The purpose of the control plant is to maintain a working environment that is acceptable in terms of any statutory regulations and the custom and practice within the industry. So the effectiveness of a control system is measured by the amount of dust or fumes it controls. Efficiency, on the other hand, is measured by the amount of power it takes to do the work. It is the job of the dust control engineer to produce the most effective plant in most efficient way, and the techniques of control will vary from one industry to another. All control plants will have either 4 or 5 elements as shown in figure 1. Meron tayong hood, natin yun sa figure 1. Ducting, yung yan. Ducting yan. Fan, collector, and disposal. Collector tapos dito pupunta doon sa dispose na yung dust. The collector is not always used, as many systems still discharge and filter air to atmosphere. The growing awareness of environmental matters will in time see all such system having collectors or treatment plant. Yung mga nagpo-produce ng dust sa mulinuhan. Yan. Ang dust yun. Foods. So dito dadaan muna yung dust. This is the inlet into the system and will be the single most important element in determining the effectiveness of the control plant. A study of the dust or fume producing process is necessary to ensure that the twin aims of effectiveness and efficiency are met. Foods that totally enclose the process for maximum effectiveness, however, prevent the operator from carrying out the process for which the control was needed in the first place. There are 4 rules of this for the design of effective foods expected of the process. 1. The hood should be as close to the source of generation as possible. Dapat malapit siya. Para kung nagsasamod na daspan, dapat hiraranin mo yung daspan. Hindi mo pa flying doon. So the location and shape of the hood is such that the contaminant is flowed into the hood, so capturing. 3. The air flowing past the source and into the hood has a velocity at the origin greater than the velocity of escape of the contaminant. Okay. Kasi para makapure siya, mas mabilis. Ay higop. Number 4, the hood is located so that the operator is never between the source and the hood. So with these rules, 4 types of hood are involved. The total enclosure. This ensures that the process is totally enclosed, which prevents any leakage to the workplace. It is rarely used except for dangerous materials such as radioactive particles in the nuclear industry or biological particles in drug industry. This technique is used on bucket elevators, conveyors, and holding beams. Wala kang access. Okay? Boots. These are really enclosure with one whole side removed where the source is deep within the boot. Ito may opening. They are particularly suitable where the particles are not moving at high speed. For example, wheeling and weighing operation. A development of simple boot is the laminar flow system, which uses a nominal velocity at the pace of 0.5 meters per second. As the airflow is laminar, all parts of boot are subjected to its effect. Next is the capture hood. Ito yung capture hood, flow hood, capture type flow hood for 4 days. Papaikot siya, mga butas, so papasok doon. So in many processes, it is not possible to use enclosure or boot without imposing an acceptable operational restraint. The hood must be placed at some distance from the source. The natural projection of particles will not necessarily be into the hood and may be needed in the opposite direction. To be effective, this hood requires a high phase velocity to give control up to 10 meters per second. Hoods for controlling fumes fall into this category, especially on tanks and mats. Septor hoods, ito yung mga nakikita nyo na, common. These derive their name from the method of entrainment. The hood is placed in the path of the particle and uses the momentum of the particle to assist in control. It is important to have a clear understanding of the process, the direction particles take, and the movement of air created by the process. Grinding wheels release dust and over the top of the wheel, and considerable air movement is generated by the process. Therefore, these are ideally suited to control by receptor hood, figure D. Yan. Nakikot niya pa gano'n. Pag nag-grind ka, so tapon mo dito. So ito naman, yung mga paint. So may vapor dyan. Papunta doon. So number 2, for other discussions, check the documents and the reference. Marami rin ito doon i-discuss. Kulang tayo sa oras. So basic lang tayo. So ducting. Ano naman yung ducting? So the gauge of the duct or your thickness should be taken into account of the nature of particles in the operating pressure of the system. Number 2, the method of construction usually encountered on the lap form, welded, and slip joint and plants. Encounter nyo na ito sa air conditioning. 3, conditioning, saka, ayun, yung mga ducting. 3, the construction material should be selected to withstand the operating conditions any conditions of the pollutant. Galvanized sheet, steel, and black mild steel are the most common for general work. Corrosion or heat application will have ducting constructed in stainless steel or plastic. For standard gauges in millimeter for bios work are ito, general dash 0 to 450 mm width. Ang thickness mo is 1.0 mm. This is for general dash work. Ito naman yung light duty work 0.8 mm. Ang bench mo, itong thickness. For 45 mm and above, so ito, bench, kapal. So, all ducts over 450 mm flange, ito naman. So, ibig sabihin dito, all duct 450 mm dapat naka-flange. So, ito ganun din. This is for boundary work. Okay. And then, for other work, so ito na yun. Okay. Boundary work, oil and with glooms, yan yung mga data niya. Number 5, the design of ductwork must ensure that the plant is both effective and efficient. Sharp bends and abrupt entries of branches into main cause unnecessary pressure loss. Incorrectly sized duct result in high pressure losses or blockages due to fallout from velocities being too low. The duct number 6, the ducting should be adequately supported and fitted with inspection doors or ports. Number 7, determination point in any system is the discharge code, and many designs are used. Fans and lower. Fans is a basic term. So, and selecting fans, wait now. Yeah. Fan engineering is a basic technology with its origin in ancient times. Matagal na yung may fans. It was developed from the wheel and pump as the need grow for continuous quantities of moving air at low pressure. Without the fan, a system will not function, and it is therefore necessary to select the fan to ensure both effective and efficient running of the plant. A selection of the fan types together with application data is shown in figure 4 and 5 and table 1. So the figure 4, letter A is the axial flow, letter B, propeller, and C, bifurcated. Type ng fan. And dito naman sa centrifugal types, merong A, centrifugal, B, paddle or radial threaded, C, forward curve, D, backward curve. Ito yung laman itong centrifugal fan. Okay. Mga type ng sauce. So yung application data for fans. So ito, pressure volume is 2.5 inches, tapos high volume, tapos ang efficiency, heating and ventilating ang industry niya, normal drive type direct. So general use for ventilation, heating, and minor fume work or low pressure system. Ito yung mga type ng fan, yung application niya. Okay. Yan. Yung pressure limit, tapos yung type of drive. Ito yung mga application. Pwede ko na basahin isa-isa. So, fan performance and loads. In selecting a fan for a system, the two most important characteristics to consider are the volume and pressure. This can be said to be the movement of air in cubic meter per hour against the system resistance, which is the millimeter of water. And there are other units nito. As the majority of the system operate at normal temperature and altitude, density is usually ignored. If the system is to work at temperatures and altitudes other than 25 C and sea level, then density must be considered in the selection. So, meron tayong discussion dito dun sa matandaan. Meron to sa mga PowerPoint group. When the speed is changed, it is more prudent to check the performance from the following fan laws. So fan speed varies, the size and density is constant. Andito yung consideration mo. 1, volume flow rate directly as fan speed is the volume 1 divided by volume 2 is equal to speed 1 over speed 2. Number 2, pressure varies as the square root of the fan speed. So pressure 2 over pressure 1 is equal to speed 2 squared over speed 1 squared. Number 3, power varies as the cube of fan speed. Power 2 over power 1 is equal to speed 2 square cube over speed 1 cube. This is for fan speed varying and with size and density constant. Same size. Other theory, sunod kayo sa fluid machining ninyo. Mabatal sa fans. Discussion yan. So example na lang tayo. A typical example will illustrate this use. A 600 mm diameter paddle bladed centrifugal fan delivers 5,100 cubic meter per hour against a resistance of 200 mm water and absorbs 5.6 kilowatt when running at 1665 revolution per minute. The motor for driving the fan is 7.5 kilowatt at 2-pole speed through B belt and pulleys. What would be the new speed, pressure, and power required for the volume to be increased to 7,000 cubic meter per hour? So given is the 5,100 cubic meter per hour, 200 mm water gauge, 5.16 kilowatt, 1665 RPM, 7,000 cubic meter per hour, new, yung bago, required the new speed and power required. Solution, so yung ratio ng formula, 7,000 over 5 is equal to new speed divided by 1665. So new speed is equal to 7,000 times 1665 over 5,100 is 2285.29. Then the new speed over 2,000 is equal to 2285.29 squared over 1665 squared. So new pressure is 376.77 mm water gauge. And the new power divided by 5.16 is equal to 2285.29 cube over 1665 cube. The new power required is 13.32 kilowatts. Wait. So ito, inayos ko lang. Lagay ko yung formula, then solution, formula, then solution, formula, then solution. So ganyan tayo, kalimutan ko lang ilagay. So dapat meron ganyan lagi. Formula, then solution. Next is the collectors. The function of the collector is to separate the types of collection, the infant dust or fumes from the air stream and deposit it in a convenient form for ultimate disposal. Ito may bin. The four most common types of collectors are cyclones, public filter, wet collectors, and electrostatic filter. Each of the above types has been developed to meet the needs of industry, and a brief description here will enable the engineer to make a start in the selection of particular application. First one is the cyclones. There are two basic designs in use. The first is the general purpose large diameter cyclone, additionally used in metal polishing and wood-based structure. Large diameter. The second is the so-called high efficiency small diameter cyclone used in groups for pre-separation or metal grinding exhaust. If the cyclone is to remain in use, it will be confined to those operations where collection of fines is part of the overall system. This is because they are relatively inefficient on the smaller particle sizes and release an unacceptable amount of discharge into the atmosphere. So ito yung mga parts ng mass collection. Dirty gas, pasok dito, labas dito. Number two, wet collectors. There are two types, the self-induced spray and the present spray. So wala tayong figure dito. So many designs have been developed to suit specific dust or fuel problems. And it is now possible to use wet collectors on the treatment of solid and fumes down to very small particle sizes. So type 1, self-induced spray wet collectors. This is the most common type and relies on its separating action by the induced air from the fan, pulling the contaminated air through a curtain of water. It is simple in operation with no pumps or moving parts except for the fan, which is set on the clean side of the collector. Next type is the spray type collectors. In this system, water is sprayed or cascaded onto the contaminated air directly through back towers, and the fumes or dust are washed away by absorption. Parang cooling tower. Number 3, public filter. So, nakita yung figure ng public filter. Kala. Public filter are capable of separation efficiency approaching 100% if correctly applied. The ideal filter is permeable to the air stream, but not to the dust requiring separation. Separation occurs by impacting of the dust particle upon public filter, resulting in a dust cake forming on the fabric. Two methods are used to remove the dust cake, both of which require interruption of airflow. Stop. The difference in dust cake removal conveniently divides filter into intermittent and continuous rating. In the intermittent type, the pressure increases with time up to pre-arranged level. The airflow is steady stopped when the fabric is mechanically shaken. In continuously rated filter, the filter rises to a low set point, after which it remains constant across the filter as a whole. The cleaning is done by isolating a part of filter from the airstream, and that section is clean. Intermittent filters are best suited to small applications which allow the process to be stopped at intervals. The interval used is 4 hours, morning or afternoon shift. Mechanical shaking is done by either hand or electric motor. Yan, may napakita yung mga motor dyan is exhaust. Ito naman sa shaking. The application of this filter is limited to the incoming dust burden of the order of 5 grams per cubic meter and is known as noisance dust. Continuously rated filter have whole section of the filter shut off from the airflow, and then those sections are shaken or cleaned. Shaking is carried out in sequence usually by a electric motor. Where the filter is cleaned, it is done by a jet of compressed air being blown on in reverse of the airflow to the public. The system does not require whole section to be shut down, as the reverse flow is carried out when the filter is on speed. Typical applications are pressure input plants, clean room filtration, and nuclear processes. Last is the electrostatic precipitator. These remove particles by means of applied electrical forces and are used extensively on cement and fly ash removal from air steam. The particles are first given an electric charge in a then passed to an electric field to apply a precipitation on them. They are then captured on collision surfaces, normally an electrode. The collision surface is then cleaned by wrapping or water wash, and dust collected in a hopper below. The efficiencies achieved are 10% of particle sizes above 1 micron. They are cheap to run, but the capital costs are high, especially for large collector. In recent years, small units have been developed to control oil and welding tubes. For the disposal, many control plants fail in their objective when the polluted waste is removed from the inlet. The practice of dropping dust into sealed bin at the base of the collector is both sensible and practical. It is when the bins are to be emptied that a secondary dust problem arises. If the waste is simply put into large container with no control, dust will be released back into the space. If dangerous dust are being collected, sealed inner liner to the dustbin can be used, thereby preventing the release and protected pa rin. On the larger installation, the collected dust is retained under sealed conditions at all times, and the discharge from collector is by rotary valve and conveyor. This will feed into valve containers for further processing. In case of fumes, these are collected by absorption into liquors, and these liquors are treated in an effluent tank separate from the fume plant. So system design and application. In selecting the best system to control the hazard, the following should be noted. 1. The problem must be surveyed under actual working conditions and data collected and recorded in a logical manner. The survey must establish A. The origin of the dust or fume in its nature. Is it toxic, explosive, or hazardous in any way? B. The process which produces the contaminant. Is it wet or dry? C. Whether the problem can be solved by elimination of the process. D. Sources or sources of the problem. Does it occur at more than one point? E. Do any special regulations apply to the hazard and are the material being handled listed in any published form as having control limits? F. Is a control system in use at the same time of the survey? Having completed the survey, the next stage is to draw the system showing the sources of dust and black pan. So, mechanical. Drawing yan. An assessment must then be made on the air volumes and velocities required control, giving control. This is largely a matter of experience. As air entrainment rates are derived empirically, it is possible to calculate the rates, but is unusual in general engineering. There are published lists for air rates, and many companies have their own standard air rates. So CFM and airflow rate now ng dust collected. So dito, mga example. Table 2 shows show rate for metal working machine. When the total air volume has been established, the collector and fan can be sized. So the total air volume and the type of dust will determine the size and the type of collector will be used. Table 3 shows the type of collector for various applications. So application, table 3, sound conductors, ang type mo is self-induced collectors, etc. Ayan. At application, side loss naman, woodworking engines and separation. Sa table 2, andito yung mga grade, grinders, ang size mo, ito yung air volume. So, yung convert this na sa CFM. So, yan mga data mo. Kung walang data, meron tayong minimum. Check sa catalog, ano yung mga exhaust niya. Okay? Exhaust to. So, to size the fan, it is necessary to know the total air volume and the pressure in the system. These are calculated from the losses in the system on the longest or index leg and begin with the hood. The hood entry loss can be expressed as 0.6 of the velocity and is accurate enough for the first estimate. The losses are then calculated on the velocities in the duct. Each change of direction means a small loss in its length of duct. Added to the pressure drop loss across the collector and the outlet losses, this gives the total static pressure required in the system. First trial. The formula used in the calculation of system losses for first estimate table here is the loss in water millimeter per length of duct is velocity squared at 1.243 over diameter of duct. So itong velocity head, yan yung kukonsume mo. So makukuha mo yung first estimate ng pressure drop. So then check mo na yung duct size mo. So velocity head or velocity pressure is the pressure required to accelerate the following mass from rest to its flowing velocity. So the velocity pressure in water is velocity meter per second squared divided by 4.04. So check nyo lang kung saan galing yung 4.04. The static pressure is the pressure to overcome resistance and is expressed in millimeter of water. The total pressure is the sum of velocity and static pressure. So, yeah. So, minsan sa selection mo, yung pressure sa catalog is nakalagay total static pressure. So, static pressure ka lang. Pag total pressure nakalag, so, total pressure kasama yung velocity. So, system design and application. The basic formula for air flow under all conditions is Q is equal to AB. And where Q is equal to volume, cubic meter per second, A area, and B velocity. The nominal velocities used in dust and pure control depend on the material being handled. But the following will suffice for most work. This is recommended na. So ito. So metal working duct is 20 meter per second. And branches niya is 20 meters per second. Yung ito naman sa woodworking and light dust, 20 meters per second yung duct velocity and the branches 80 meters per second. Gases and vapor ducts, velocity is 10 meters per second and the branches 9 meters per second. So yan mga rules. So it is now possible to calculate the total system resistance and select a suitable pan and collector. The following will illustrate the use of the formula. So example number 2. Number 1. Meron pala example number 1 yung panalo. So given, ito, a simple duct system length of 15 meters serving a double end grinding machine requires an exhaust volume of 6,000 cubic meters. So itong length na to, equivalent length na to kasama ng mga fittings. The duct velocity, fittings na except on sa hood. The duct velocity will be 23 meters per second, giving a diameter of 300 mm and a velocity pressure of 22.41 mm. Given the length is 15 meters, exhaust volume 6,000 cubic meters per second, duct velocity 23 meters per second, diameter is 300 mm, velocity pressure 22.1. So require the total system resistance and select a suitable pan collector. So selection, the full loss is 0.6 times 32.41 is 19.45 mm of water. So duct losses in 50 mm meters is 20 squared plus 1.240 over 350 is 109.59 millimeter of water. So the total pressure, velocity pressure plus static pressure is 32.41 plus 109.59 plus 19.45 is 161.45 mm of water. This figure must be added the pressure drop across the collector, which in this case could be a well unit having a drop of 150 mm. So add mo yun, magiging P1 1.45. So the pan would then be selected to handle a 6,000 cubic meter per hour and a total pressure of 311.45 mm water. Total, as this is a high pressure pan, so it would be a centrifugal backward laminar tank. Now, testing and commissioning. After lahat ng mga installation, pwede rin to. As the same, after the plant has been installed, it will require a test to determine whether the design meets the original objectives. In this assessment, the effectiveness of the plant will be established and at the same time, a record made showing the engineering parameters. The precise nature of the test will depend on the articles being controlled. It is only where the contaminants are listed and known to be dangerous that special testing needs to be done. This work requires on-site monitoring of the workplace using air samplers and the expert services of an industrial hygienist. Okay, so this is the end of the dust collection system.